Find the eigenvalues and eigenvector of a matrix A. So this is the 4x4 matrix and we need to find the eigenvalues for that. Let me write the characteristic equation. So this is the determinant of lambda I minus A is equal to 0. On solving this, we get the eigenvalues, right? Where this I is the identity matrix, the 4x4 identity matrix. So let's solve this. The determinant of, okay, if I multiply this lambda with this identity matrix, what I get? This is the 4x4 identity matrix. And when lambda is multiplied with this, we get lambda 0 0 0, 0 lambda 0 0, 0 0 lambda 0 and 0 0 0 lambda. And then we need to subtract this A given matrix from this. So when we subtract this from this given matrix, we get lambda minus 1 to be the first element of the first row, then 0 minus 1, that is negative 1, then 0 minus 1 again, that is negative 1, and then 0 minus 1 again we have negative 1. Likewise the second row, so this is 0 lambda negative 1 negative 1, and then 0 0 lambda minus 1 0, then is 0 0 negative 1 lambda minus 2. So when solving this determinant, we get the equation as lambda minus 1 into lambda minus 1 into lambda minus 2 to be equal to 0. And from here we get lambda to be equal to 1, 0, 1 and 2. So we are getting the 3 eigenvalues for lambda, and lambda equal to 1 is of multiplicity 2. Eigenvalue 0 is of multiplicity 1. The eigenvalue 2 is of multiplicity 1, but eigenvalue 1, 1 is of multiplicity 2. We are getting the eigenvalues to be 0, 1, 1, 2. So the eigenvalue lambda 1 equal to 0 is of multiplicity 1. The eigenvalue lambda 2 equal to 1 is of multiplicity 2. The eigenvalue lambda 3 equal to 2 is of multiplicity 1. Right? So now we need to find the eigenvector. To find the eigenvector, we use this equation, the set of homogeneous equations. First, when lambda 1 is equal to 0, this is your lambda I minus A, and this is your x, and this is 0. We write lambda I minus A to be for lambda 1 equal to 0. For that, we have already calculated lambda I minus A to be this, right? Just put lambda equal to 0 over here. We get 0 minus 1 minus 1 minus 1, 0 0 minus 1 minus 1, 0 0 minus 1 0, 0 0 minus 1 minus 2, right? So first we have put lambda equal to 0 and we are getting minus 1 minus 1 minus 1 minus 1 to be in the first row, then 0 0 minus 1 minus 1 to be in the second row, then 0 0 minus 1 0 in the third row, and fourth row is 0 0 minus 1 minus 2. And for x we write x1, x2, x3, x4. It is your 4x4 matrix given to you. The A matrix is 4x4 matrix. So write 4 variables for x, and this is your 0 as in the column vector, right? Okay, let's get the equations. So from here we are getting minus x1 minus x2 minus x3 minus x4 to be equal to 0, or we can also write this as sum of these 4 variables to be equal to 0, right? Okay, then second equation, this is minus x2 minus x3 to be equal to 0. We can write this as the sum of x2 and x3 equal to 0. Then minus x3 to be equal to 0, that is x3 equal to 0. And then minus x3 plus minus 2 into x4. So that is x3 plus 2 into x4 is equal to 0. So these are the 4 equations we have got, and from here we are going to get the value of x1, x2, x3, x4. So from here we get already x3 to be equal to 0. Yes. Putting the value of x3 into the second equation, we get x4 to be equal to 0. Yes. So from the first equation we get, when putting x3, x4 to be equal to 0, we get x1 equal to negative of x2. Whatever value I give to the x2, x1 is the negative of that. So let me take x2 to be equal to, let's say, t. Then x1 is negative of t, right? So these are the 4 values we have got: x1, x2, x3, x4, right? Okay. Writing the eigenvector now, that is x1, x2, x3, x4. Okay, what is x1? It is negative t. x2 is t. x3 is 0 and x4 is also 0. We can write this further as, if I take t outside, I can get this as minus 1, 1, 0 and 0. So from here we get the basis of eigenspace. So this forms the basis of eigenspace. This is the eigenvector. You have got this to be your eigenvector, and you can take t to be of any value. T is belonging to the set of real numbers, right? So this is the form of the eigenvector. You can give any value to the t, and when taking t outside, this becomes the basis for the eigenspace, right? So thus, let me write this: minus 1, 1, 0 and 0. This forms the basis for eigenspace. So this is for all about the lambda 1 equal to 0, the eigenvalue lambda 1 equal to 0. For this eigenvalue, we have got this to be our eigenvector and this to be the basis for the eigenspace. Next, now we are working on when lambda 2 is equal to 1, the another eigenvalue lambda 2 equal to 1 of multiplicity 2. So when lambda 2 equal to 1, we need to get this format. This is your x1, x2, x3, x4 and this is 0, 0, 0, 0. Please remember lambda I minus a into the vector x is equal to 0. This is the format to get the eigenvector and also to get the basis for the eigenspace. Now we have to put lambda 2 equal to 1 in this. We have already calculated this. So we just need to put here the second eigenvalue that is equal to 1. Please remember we have got the eigenvalues to be 0, 1 and 2, right? We have taken our 0 to be lambda 1, that means this is the first eigenvalue. We have taken 1 to be the lambda 2, which means this is the second eigenvalue, and this to be the third eigenvalue. Don't confuse with lambda and lambda 1. These are the eigenvalues we are putting over here for this lambda, right? So writing this, it is 0, minus 1, minus 1, minus 1. Then is 0, 1, minus 1, minus 1. Then is 0, 0, 0, 0. And is 0, 0, minus 1, minus 1. And now getting the first equation from this, we get x2 plus x3 plus x4 to be equal to 0. And then we get x2 minus x3 minus x4 to be equal to 0. We don't get any third equation from all these 0 row. And then the fourth equation, x3 plus x4 to be equal to 0. On adding these two equations, we get 2x2 to be equal to 0. 2 is non-zero, right? That means x2 is 0 And from the last equation we get x3 to be equal to negative x4. Whatever value I can give to x4, x3 is negative of that. So let's give x4 to be equal to t. Then x3 becomes negative t. So we are having these two values for x3 and x4, and also we are having x2 to be equal to 0. But what about x1? There is no x1 over here, right? So we can give x1 any value. Let's say x1 is equal to s, where s is belonging to the set of real numbers and this t is also belonging to the set of real numbers, right? You are free to give any value to x1. So writing the eigenvector now, x1, x2, x3, x4. For the values, x1 is equal to s, x2 is equal to 0, x3 is negative t, and x4 is equal to t, where t and s both belonging to the set of real numbers, right? Okay, so let's put all these values over here. x1 is s, x2 is 0, x3 is negative t, and x4 is t. We can also add these two vectors to get back our this vector. For that I am writing s 0 0 0 and 0 0 minus t. Can I write like this? When you add these two vectors, you will be getting back this vector. And now when taking s common from this, 1 0 0 0, we get this, plus when taking t outside, we get 0 0 minus 1 1. So these two now forms the basis for the eigenspace, right? We have got two bases over here. So this is your eigenvector for the values s and t belonging to the real numbers, and these two are the bases for the eigenspace. So thus, if you remember that lambda equal to 1 is the eigenvalue of multiplicity 2, right? So what basis we are getting? 1 0 0 0 and 0 0 minus 1 1. So this is basis of eigenspace. And now the third case, when we are having the eigenvalue, third eigenvalue, that is equal to 2 of multiplicity 1. And for this we get the matrix to be this one, when now putting the third eigenvalue to be equal to 2. So 2 minus 1, that is 1, and minus 1 minus 1 minus 1, right? Then 0, this is 2, minus 1 minus 1. Then 0 0 2 minus 1 1, and then 0 0 minus 1, and this is 0. So this is 1 minus 1 minus 1 minus 1, and then is 0 2 minus 1 minus 1, and then is 0 0 1 0, and then is 0 0 minus 1 0. So now the first equation becomes 1 into x1 plus minus 1 into x2 plus minus 1 into x3 plus minus 1 into x4 equals to 0, right? Similarly, second equation becomes 2x2 minus x3 minus x4 equal to 0, and then x3 equal to 0 and minus x3 equal to 0. So these two implies that x3 is 0, right? And from the second equation, if I put x3 equal to 0, I will be getting 2x2 equals to x4. x3 is 0, and from the first equation, from this equation, and from the first equation, if I put x3 equal to 0 and x4 as 2x2, right? So here x4 as 2x2 and x3 is equal to 0, I will be getting x1 minus x2 plus 0 minus 2x2 equals to 0, that is x1 minus 3x2 equals to 0, or x1 equal to 3x2. So now we are having the value of x1 to be 3x2 and x3 is 0, and from here we get x4 to be equal to 2x2. So if I put x2 equal to t for t belonging to the set of real numbers, what I am getting? The value of x1 to be, let's write the eigenvector now. x1 is 3x2, that is 3t. right? For x2 equal to t. x2 is t, x3 is 0 and x4 is 2x2. That is 2 into t. For x2 equal to 2 and t belonging to the set of real numbers. And when we take t outside, we are getting here 3102, right? Where t belonging to the set of real numbers. So this represents the basis for eigenspace. For eigenvalue equal to 2, having the so thus the vector 3102 forms the basis for eigenspace for eigenvalue equal to 2. Alright, thank you, stay blessed.